Hello, my name is William Bridges. I'll be giving you a brief presentation on our paper, Pressure Relief Systems and SIS, their common weaknesses in field implementation. You can find out more about myself and my company online at our website. We're going to be discussing three major problems that we see in field implementation of these high integrity systems. Any of these deficiencies can cause an order of magnitude reduction in the reliability of the components. The first is design failures. I'll use PSVs as an example here. If you needed 3 PSVs to open, as an example, to give you the full relief capacity per the limiting case, then it's best to have 3 out of 4 relief valves instead of 3 out of 3 relief valves. The worst case we've seen is 15 out of 15. If you have 15 out of 15, then your PFD, your probability of failing on demand, is 15 out of 100 roughly, instead of 1 out of 100. But if you had 15 out of 16, your PFD would drop again to about 1 out of 100, which is about where you want it. So you need to design in extra capacity to account for common cause failure of the similar devices. The second problem area we see is inspection, test, preventive maintenance planning. Here, many times people don't plan for the common cause error of humans doing the same task on similar parallel channels. So let's say you have a safety instrumented system and it's got 3 pressure sensors. If the same person inspects channel 2 and 3 on the same day back to back after they do channel 1, the probability they'll repeat an error made on channel 1 inspection or test is about 100%. So it's better to stagger maintenance between inspection of redundant channels. The staggering could be either 3 days between them by the same person, or have a different person do the inspection test check on the same day. The third error that a lot of people make is in consideration or lack of consideration of the human error during interventions with the devices. This applies to everything, but I'll just take PSVs again. If the probability of leaving a block valve closed under a relief valve is 4 out of 100, then that is going to dominate the failure rate of that relief valve. So instead of giving you a probability of failing on demand of 1 out of 100, you might have 5 out of 100. We looked at relief valves in the field as one test for the paper, and we looked at 400 relief valves for a client in Saudi Arabia. And this client had had some issues with relief valve positioning in the past, but when we checked it, all the block valves under the relief valves, upstream and downstream of the relief valves, were open as they should be. But we did find that about 10 to 13% of the block valves did not have their car seals. This does not cause an immediate problem, but increases the probability of problems in the future. Thank you.